Scott, I just wanted to talk to you about something that you wrote about recently involving mass testing that I don't think's gotten enough attention, and I'm hoping maybe you can explain it to our audience because I'm a little unclear about it. But you wrote about the idea that you might be able to do mass testing, 50 people, 100 people at a shot on a daily rotating basis, employees going to work. Effectively, it sounded like spitting into something, collecting all of that, sending it off overnight, and then finding out whether those 50 or 100 people have it. If they do, or if somebody's positive, then they retest everybody in the group. If they don't, everybody's clear. I don't know if that's a good explanation of it, but explain what you were talking about.
All right, so just briefly, there's different tools for different purposes. You have the rapid tests like the ID Now, very good in the provider's office for getting a quick answer. You have the PCR-based tests, very good for getting a very accurate answer. You have to wait for overnight. And then you have other platforms that are these high-throughput platforms that you could literally test thousands of people at simultaneously. And what you would do with those platforms, and this includes next-generation sequencing, so I'm on the board of Illumina, and they have this platform. But think of Boeing. Boeing wants to test their entire workforce. Let's say it's 10,000 people in a plant. What they might do is break those people into pools of 20 or 50 or 100, have people spit in tubes, test the pool. So you test 100 people at the same time, and then if you get a hit on a pool, then you'd go back and test everyone individually. But if you have a low index of suspicion in an asymptomatic population and you just want to use it for routine screening, you don't need to test everyone individually. You could test people in pools. The reason why next-generation sequencing is a good tool for this is that PCR looks for 2 amplicons. Next-generation sequencing could simultaneously look for 200 different parts on the virus. And so if you're trying to screen a pooled sample where you want something that's very sensitive, very specific, next-generation sequencing, there's other platforms, too, that can do this, that can look at a pooled sample and give you a sensitive, reliable answer. The point is that there's no one-size-fits-all test. I think the key is to trying to adapt the right technology to the right purpose. That's what we should be doing. So, for example, the ID Now isn't a good machine if you're screening an asymptomatic population and you want to be 100% accurate, like in the White House. You might want to use PCR or the Cepheid Gene Expert. That's a much better machine. You're not going to get false negatives with that machine.